Good morning to all. This is Arun. Today we are going to see about the queue. In the last class and the before class, in the first class we have seen about the introduction to data structure. In the next class we have seen about the stack. Now you are going to see about the queue. So first of all we will see something about stack, then we will go to queue. Stack is last in first out. It is also a data structure, linear data structure. Now we are going to see the queue. Queue is also an abstract type or a linear data structure, just like a stack data structure. So it is also like a stack data structure, but the adding of an element and removing of element differs here. They are last in first out. Here first in first out. The element which comes first, it will be removed first. In the stack, the element which comes last, that will be removed first. That is the difference between the queue and the stack. So here, in which the first element is inserted from the one end, that end you call it as rear end or you call it as tail. So in which you are going to enter an element, that end you call it as tail, and the removal of existing element takes place from the other end called front, also called head. So inserting end you call it as tail, removing end you call it as head. That is the queue. So this makes the queue as first in first out data structure, which means that the element inserted first will be removed first. Here there is an example. If you go to a ticket counter to buy a movie tickets and are first in the queue, if you are first in the queue, then you will be the first one to get the ticket and go to the theater, first person to go to the theater. That is what the real example for queue. The process to add an element in the queue is called NQ. So if you add an element, that process technically they call it as NQ, and the process of removal an element from the queue is called DQ. If you enter element, that you call it as NQ. If you remove an element, that you call it as DQ. Now we will see some of the basic features of queue. Okay, like stack, queue is also an ordered list of element of similar data type. Like stack, queue is also an ordered list of element of similar data types. Queue is a first in first out structure. Once the element is inserted into the queue, all the elements inserted before the new element in the queue must be removed to remove the new element. Here the pick function is oftenly used to return the value of the first element without dequeuing it. So these are some of the basic features of the queue. Now we will see the structure of the queue. See here, this is the structure of the queue, that is the array 1, 2, 3, 4, 5, 6. So for example, we can declare it as int a of 5. So array starts from 0, so it occupies 6 elements here. So NQ, this is the tail in which you are going to enter the element. This is DQ in which you are going to remove the element. You call it as rear, or you call it as tail, you call it as front, or call it as head. So here, see here, NQ is the operation for adding an element into the queue. DQ is the operation for removing an element from the queue. This is the queue data structure. Now we will see the implementation of queue. See here, queue can be implemented using an array, stack, or linked list. The easiest way of implementing a queue is by using an array. You can implement either using an array or linked list. In the next class, we will see about the linked list in detail. Before that, you should have some basic ideas about the stack and the queue. So initially, the head, that is front, and the tail, that you call it as rear. In the rear end you are going to insert the element, in the head you are going to delete the element or remove the element of the queue. Points at the first index of the array starting the index of an array from 0. So here it points, see here it points both the head and tail initially. As we add elements to the queue, the tail keeps on moving ahead, also pointing the position where the next element will be inserted. See here in the next diagram. So initially it is both the head and tail in the 0th position. Next, when one element is inserted in the head, inserted in the tail, it will point where to insert the next element. So A of, for example, 0, next element will be inserted in 1, next element will be inserted into the 2. First 27 is inserted, next 19 is inserted, next 17 is inserted, and then 7 is inserted. So this is how we are going to adding the elements to the queue. Here you are going to remove the element from the queue. So how we are going to remove the elements? Which element will be first removed? So which element is inserted first? 27. So that is the concept of queue. Which element comes first, that element will be removed first. So now we will see the removal of elements. See here the A diagram. Which element is removed? First 27. Next which element will be removed? 19. Next 17. If this 27 is removed, the head will point the next element 19. Okay. If the 19 is removed, next the head will point the 17. If the 17 is removed, then the head will point the 7. If 7 is removed, the queue becomes empty. Okay. Now we will see below. So this is the explanation for the above diagram. See here, when we remove an element from queue, we can follow two possible approaches mentioned A and B in the above diagram. In A approach, we remove the element at 8th position and then one by one shift all the other elements in the forward position. In B approach B, we remove the elements from the 8th position and then move head to the next position. In approach A, there is an overhead of shifting the elements one position forward every time we remove the first element. In approach B, there is no such overhead, but whenever we move the head one position ahead, after the removal of first element, the size of the queue is reduced by one space at each time. At the end, the queue becomes empty by removing every element one by one. Now we will see the algorithm for NQ operation. Check if the queue is full or not. First, it will check whether the queue is full or not. If it is, next step 2, if the queue is full, then print overflow. If the queue is occupied, for example, if the queue has a size of A of 10, if it is occupied by 11 elements, because array starts from 0, then it will show overflow and exit the program. If the queue is not full, then increment the tail and add the element. Now algorithm to DQ operation. Check if the queue is empty or not. If the queue is empty, then print underflow error and exit the program. If there is any element, if not empty, then print the element at the head and increment the head. So this is the algorithm for DQ operation. So these are the algorithm for NQ operation and DQ operation. So here also you are going to push, you are going to pop, you are going to peep what all the operations you performed in the stack. Here also you are going to perform those operations. We will see one simple program. See here, so header file using namespace std, I'm sizing the defining the size as 10, class name is queue. So the queue should be always, starting letter should be always the caps. So opening the bracket for class int A of size. That means here already we have defined the size of array is 10. So here it will be A of 10. That means. So int rear means I have already said it's a tail in which we are going to insert an element. Here the int front. That means you are going to remove the element in the front end. You are going to add element in the rear end. That is at the tail. So public. So in the last class itself, while I am taking the stack program, I have said that if there is no access specifier here above the declaration part, it will be declared as a private. So now here public q. So if the class name and the function name are same, then that you call it as constructor. You will be studying in C++ about the constructor. Okay, now the function rear equal to front equal to -1, the q function. Now declaring enq, dq and display functions. So this is the prototype void enq index int dq function, next to void display function. Here no return type, function name, arguments, return type, function name without arguments, no return type, function name without arguments. So here the class ends. Now we are going to see the one by one function. So last class I have already said how to write a function. See here, void return type, class name q, scope resolution operator, function name enq and arguments. I am opening the bracket for that function. If front equal to -1, front plus. That means you are going to add, you are going to void q, enq means what? See here, enq means if q is not full, then increment the tail. So enq means what? You have to see, you have to recall that enq means you are going to add an element into the queue. That is what here we are going to perform. That is the function first we are going to perform. See here, int f equal to -1, front plus. That is you are going to, if rear equal to size -1, q is full. If it is empty, then you can insert the element. If it is full, then can't do it. Next dq, that means you are going to remove the data from the queue. Here you are adding the data to the queue. Here you are going to remove the data from the queue. See here, int q, so second function. So here see int dq. So int is the return type, q is the class name, scope resolution operator, dq is the function name. So return a plus front. Okay, it is already explained in the diagram itself, above diagram itself. Now function to display the q element. So we have inserted the element, that is we have added the element to the queue, we have removed the element from the queue. So now this is the explanation given above. We will see that. See here, this is the explanation. You go through it. Now this is the function to display the q elements. See here, void q, scope resolution, display function, int I, for I equal to front, I less than or equal to rear, I plus cout, that is to print the elements. Now we are going to the main function. In main function only we are going to call the function, all the functions, what all the functions we have performed. Okay, so inside the main function, first we are creating the object. This is the class name and the object is q. This is how we are going to create the object. First we will, enq means we are going to insert the element, q dot, that is q object dot enq. First you are entering the element 10, next you are entering the element 100, 1000, 1001 and 1002. Next you are going to perform dq, you are going to delete the element. So again, that is we are inserting the element 1003, again we are dequeuing. So this is how we are going to perform, or finally we are displaying q dot display, then return the, this is the end of the program. So see here, return a of 0 returning the first element, shifting all the other elements. So a of I equal to a of I plus 1 tail minus minus. So this is the basic thing about the queue. In the next class we are going to see about the stack using linked list and queue using linked list. Thank you.